Live. You said it right when it happened. Okay, let's look at the warm-up. We have two triangles. We're looking back to probably even what you have math from like middle school, or math 1, maybe math 2. You've seen these the area of triangle before. So who can first tell me what is the formula for area of a triangle? Area of a triangle, Lincoln.
H over 2.
Okay, good. I'm going to just break it up a little bit different. It's the same thing. But B times H, so base times the height, times a half, or divided by 2, same thing. I just been writing it, and I want to match what I've written up here. So good job. So these are very simple, like again, math 1 type problems, where you have to just identify the base, the height, multiply them, then divide by 2. So, or multiply by half, either. So what is my, let's see, 1/2 base times height. What's my base in this?
8.
Okay, 8. And if we remember the units at the end, we'll just do meters squared because it's an area. Okay, the height, easy, 5, right? So essentially what we have is 8 times 5 times a half. So 8 times 5 is 40 divided by 2, 1. What are my units going to be again? Meters squared. If you're wondering how that actually happens, how do we actually get units squared? It's always because we have 8 meters as my base times 5 meters of my height. Meters times meters is meters squared. The units always work out like that. So it's one way to actually check if you're not sure. Keep all the units in it. Whatever's multiplied or crossed out, you got to just keep track. We also just know area is meters squared, units squared. So I'm going to put it up here too. Units squared. Let's do this one real quick and then jump right into the lesson. So this is kind of just prep, getting your mind in the context for today. Let's see. So we have 1/2 base times height. Let's do that one. 1/2 base. I see where you're going already. 15 times 10. 150 divided by 2. That's cool. Oh. What are my units for this one? Units? Units?
Meter squared.
Centimeters squared.
Oh, centimeters.
How could you do that?
Come on, I jumped the gun.
All right, how do we feel about this? Just finding the area of a triangle. Do we understand how it works? Feel good? Thumbs? Yes, yes, yes. I know this is remedial. It's just getting your mind in the context, okay? Just getting your mind in the context. Again, for today, we don't really have to reference the unit circle, just like yesterday we didn't. So today we are going to derive the area of a triangle using trig, specifically using sine. So this whole few days here has been the sine has been the main function. So I'm going to pause it right now. I want you just to, this is the notes, and then we have 2 example problems. So I think that's about 4 minutes. Unpause. Here we go. So the area of a triangle, we know from the warm-up, we can just, if we have all the sides, we can find it really easily. Okay, but we're going to have situations like this case where it's going to be difficult to find the height and the base here. You could use some trig to figure those things out, but we're going to use the sine. And here's the area of a triangle with trig formula. I'm going to show you how to derive this because it's part of your standard, but I'm going to give you then, below that is really the key to this whole thing. So I'm going to give you a spatial kind of understanding of what parts you use. I like to teach spatially. But we are going to derive this. So first off, first step for this triangle, I want everybody to go ahead and draw the altitude from B. So I'm starting in angle B. I'm going to the other side to make a 90-degree angle. So we're starting here. Yeah, it's going to be straight down, vertically down. And if you do so, you get 90 degrees. And that's the most direct path to get to the other side. You can see if you start to go out a little bit, really, if I'm going this way, I've just gone the hypotenuse of this little triangle here versus the side. So the most direct way to the opposite side is to make a 90-degree straight altitude. Okay, you can see that. So we drew the altitude from B. Okay. Now, if I'm looking at this Oh, I see. Let's look at, let me see where we're going with this. Point C, angles. Okay. Let's look at the area of the entire triangle first off, but we're going to label this as well. We're going to label it H. Okay. So the height, essentially. So if I was trying to find the area of this, of the area of the triangle, right, it would just be 1/2 base times height. We already know that. That's fine. But next thing we're going to do is find the area for these parts, because I may not know these parts. Okay. So how do we find? Let's see. How are we going to find side H from this triangle? What would I use for? Let's see. In reference to this angle, what would I use to find the height right here? So I'm just looking at this angle, this triangle right here. How could I find the height if I knew what this C angle was? Right, watch. Oh, sorry. We were using H and we're using K now. Sorry. K is the altitude. I just remembered from that. Okay, so we're going to go sine of C, and that's equal to the opposite over the hypotenuse. You see? Is that okay? That works, right? Okay. So once you do that, we're going to go ahead and do it from the other side. So this side is going to be K and C. That's not what I need. One second. I don't want to go the wrong way with this. So one more. Why does this happen so much? Sometimes. Right, okay. Define it in terms of H. Okay. Okay. Alright. Right. Okay. I was doing it totally right. I just questioned myself. So here we go. If I need to solve this in terms of K, what do I need to do to both sides? Multiply by A. So we know that K is equal to A times the sine of our letter C. I promise you when I get to this right here, the spatial approach, you're going to see it very quickly as far as the process. Now, looking at this, I know that A times the sine of C is equal to K, so I'm going to take that K and put it right in that area formula here. Watch what happens. Area is then equal to 1/2. Since it's A, I'm just going to rewrite it A times B times the sine of C. And that's our area formula that we're going to use. That's also listed here, obviously. But the reason why I put side, side, and the angle in between is because that's the real key to spatially looking at a problem. Spatially looking at this problem. ABC. You know that's 8 centimeters. You know that's 12 centimeters. And we know this is 22 degrees. Based on my mnemonic device here, spatial approach, 2 sides and the angle in between. Do we have enough? Do we know enough over here to be able to do this process?
Yes.
We do. Because we have the 2 sides. We have the angle in between. So looking at that now, let's go ahead and apply it to this all I did to derive the formula was remembering it's 1/2 base times our altitude, our height. So in expressing this, if I look at the sine of C, it's equal to k over a, then I just move the a over and it's just k equals 2. Then I plugged it back in. We couldn't derive that without breaking the triangle up and looking at it in parts. Two sides and the angle in between. So I'm going to go ahead and set this up. Oh, this is C. A little erased. So I know I'm looking for 1/2 a, b, and sine of C. If you're wondering, well, why do I need to look at this, the sides and the angle between? I know that I'm just looking for side A, side B, and angle C, right? What happens when you have a triangle that's DEF? Or if you're not going to use the angle C, you're going to use angle B, then you have to accommodate. And it's actually a little messier to translate this. Spatially is much easier. To translate this to the actual sides, looking at the specific triangle, that's where the errors are going to be made. Okay, many of you can do it. It's fun. It will work to do it that way. This always works, and it's obvious. Okay, so the two sides and the angle in between. So here we have the side. Here's the other side, and we have the angle in between. So let's go ahead and move this over now. And now looking at it, we got the side, angle in between, the other side. So let's go and put it in. I know it's 1/2 times my sides that form the angle. Spatially, it's just this. It's just that, the angle. Here's the side, here's our angle. We'll call it C. So in this case, all I need to do is 1/2 times one of the sides times the other side times the sine of the angle in between, 22 degrees. What mode do we have to be in for this? Degree mode. So let's go ahead and get out the calculator. Make sure it's in degree mode. Degree mode. And I am in degree mode. The sine of 22, 0.37461, 8, 12. You're in radian mode. All right, so we got here. We're here. We're going to find the area. Let's see, 12 times 8, 96. Cut that in half. 48.
96. Oh,
Oh my gosh, go to degrees. Your problems really become.
Oh man, that's a promise. Wow. All right, and then we get 17.98. It's going to be in, well, we have to look back. Because the area of this, we have to do units squared. What are my units up here?
Centimeters.
Squared, done. All right, I had to show you how to derive the formula. If you can just kind of visualize and see it, that's great. It is part of the standard, but most of math is the application of it. I think the mnemonic device, the kind of like hint here, just works every single time. If you want to try a few problems where you're reassigning the sides into ABC and the angle into ABC, you can do that. Okay. But really, we know one side, the other side, the angle in between, that's what goes into those positions. Now, example 2 just has one other little part to it. We're using the arc sine or inverse sine to find what theta is. Okay? So remember that the arc sine is not the same as the cosecant. The cosecant, secant, and cotangent are reciprocal functions. This is how we find the angle if we know the ratio of the sides. So if we know the angle, we can get the ratio. If we don't know the angle, we take the inverse sine of the ratio to get our theta. So let's look at this one. For the triangle ABC, find the angle between the sides AB and BC if the area is, so we're looking for this angle, if the area is AD centimeters squared. When they give you the area, that makes me know that I'm going to be looking for something using the inverse. If you want to make that little note, if they're going to give you essentially what we are usually looking for, that's a hint that I'm going to need some of the starting information. Work backwards that way. All right, we have one side. I got to watch time. It's weird. Perfect. We have one side, we have the other side, we have the angle in between. Okay, so let's go ahead and throw it in there. I'm going to write area first. I'm going to just switch that out in a sec. All right, here's my A value. Doesn't matter which is which because they're multiplied together. 34. Here's our B value. Sine of, do we know it? We don't know it. That's what we're looking for. I do know the area. Oh, 80 centimeters squared. These are centimeters. Centimeters. The reason why it's squared is because centimeter times centimeter is that unit squared. All right, let's go ahead and work out what we can. My trick with this, when you line these up, 1/2 of 16 is 8. 8 times 34 is something you can actually do easier, quicker. 8 times 34. 72? No. 272. No. Just kidding, I'm seeing through this. Awesome. You see what we're looking for now? What's missing? Yeah, theta is unknown. So we're looking for that. We know we're going to use the inverse because the sine function can only be applied to an angle. So we're going to have to go backwards using the inverse sign. But first, .2941. For these 4 digits, decimal places. So again, this is the point where usually we would take the sine function of an angle that we know to get that. You see, that's what we'd usually get as the answer. To go the other direction, I'm going to do the inverse sine of 0.2941. And that's going to give me theta. You see, we just take the ratio and we do the inverse. No biggie. Let's do it. Inverse sine answer. Okay, theta is 17.10. If you were in degree modes, it's degree. If you're in radian mode, it would give you the equivalent in radians. It doesn't say to find the angle in between. So I'm going to go with degrees because that's what mode is in. It's easier to find it in degrees because you can visualize it slightly quicker. All right. That's so quick. Any questions? Anything else? Nothing. Thumbs up, sideways down. Are we all up? We're good? Yeah, we are all up. Perfect. Okay, so Edmodo has your worksheet for the homework. And let's go ahead and get started on that for the last like 10 minutes. Perfect. Don't forget to subscribe.